Okay, to start with, one thing that students often misunderstand is that in projectile motion, an object's horizontal motion and vertical motion are completely separate, and that makes our calculations a lot easier. Let me give you an example. If a ball rolls off of a table and it's horizontal, uh, it's going to maintain its horizontal velocity all the way to when it impacts the ground. Now, of course, all of these examples are going to be neglecting air resistance. But as the ball rolls off the table, it's of course going to begin to fall. But when it hits the ground, it is still traveling horizontally with the same speed that it did when it left. But on the other hand, when it started to fall down, it increased its vertical velocity every second. Now, that is given in your book in chapter 2, I believe. Of course, it's easily calculated, and I'll show you how. But if an object is just dropped after 1 second, it has traveled 5 meters. Okay. After 2 seconds, it's traveled 20 meters. And after 3 seconds, 45. And after 4 seconds, it's traveled, 80 meters. And then 5 seconds, it's traveled 125. Now you see that the first second, it went from 0 to 5. And then the second second, it went from 5 to 20. And then to 45. So it's picking up speed. It's gaining velocity because of course it's falling and it's under the influence of gravity. So if something has been falling for 1 second, it's going to have traveled 5 meters. Now, how do you calculate that? Well, the formula that you need to make sure that you memorize or keep handy on a card or something is distance equals 1/2 the acceleration due to gravity times the time squared. Now, for our calculations, our acceleration due to gravity, we are simplifying into 10 meters per second squared. And if you want to make your life a little easier, instead of using 1/2, you can use 0.5. And then for the time, whatever the time is, if it's 1 second, 2 seconds, 3 seconds, you just square it and then multiply all that together, and that'll give you the distance. For instance, let's say that we're talking about the 1 second example. If it fell for 1 second, then you have 1 second, and then you're going to square that. Well, 1 squared, 1 times 1 is 1, and then that 1 is then multiplied by the 10 meters per second squared, and then by 0.5. So 0.5 times 10 times 1 is going to give you 5 meters. Okay. One more quick example there. Let's say that it has fallen for 2 seconds, and we're using the exact same formula. Okay. And so it's going to be 1/2 times the 10 meters per second squared for gravity times 2 seconds squared. So you've got 2 times 2, or not 2 times 2, but 2 times 2 because it's squared is 4. And then that's 4 times the 10 meters per second squared. That's going to be 40. And then times 1/2, which is 0.5, that's going to equal 20 meters. So if an object falls for 4 seconds under the acceleration of gravity, 10 meters per second squared, you multiply that times 1/2, then it's going to have traveled 20 meters if it has fallen for 2 seconds. Again, the big topic here in this little video clip is that an object's horizontal speed and its vertical speed are independent of one another. If it rolls off the table, it's going to continue traveling at the speed that it rolled off the table horizontally. But then it begins to pick up speed and impact the ground.